So last class I discussed about the how can you design the SR latch flip flop, SR NAND flip flop, everything we have discussed, right? So now there are the four kinds of the flip flop. Flip flop means if you connect the clock with the any kinds of the latch, it will become the flip flop, right? So that means if you want to control the inputs, we need the clock signal. If we remove the clock signal, it will be input, there will be the no change in the output, only memory effect will be there, right? So now come to the D flip flop. Okay, so SR flip flop, if by using the SR NAND latch, you can design the SR flip flop, right? So D flip flop is a one kind of the flip flop which can be used to store the information mainly. So the origin of the D flip flop is SR flip flop only. What is here? Here you can see this is the SR flip flop. If you see this one, this is the okay. So this is the SR. Okay, this is the SR flip flop. Now I will design the D flip flop. Okay, so what is the difference between SR flip flop and D flip flop? If you remember, in SR flip flop, normally the one on state we cannot use. If we want to use the one on state, that means if you want to give the input in both S and R, there will be not use condition, right? So we cannot, they are not used or forbidden condition. Okay, but so sometimes, so due to this forbidden condition, we cannot use the SR flip flop in sometimes, right? So for that, we need the one kind of the flip flop that is called the D flip flop. D flip flop is mainly used to store the input only. Okay, so if you want to retain the previous inputs, if previous outputs, or if you want to have the memory effect, so if you remove the clock, it will have the memory effect, right? So in D flip flop, it's like the flip flop is like the SR flip flop, but in we cannot use the one on condition. If you remember the SR flip flop, right? 0 0 memory, 0 1 0 1 1 0 1 0 1 1, not use condition, right? So from the SR flip flop only I will use these two conditions. So don't use that 0 0 and the 1 1. But if you need the memory, how can you use the memory effect? So if you remove the clock, so for that clock you can use the memory effect. And if we apply the 1, if you apply the clock, if 0 1 and 1 0 states are there, you will get these outputs. Okay. So for that, from SR flip I need only these two conditions. I don't need these two conditions. Now if you check these four combinations, in these and these combinations only, both S and R both are same. Okay, but in case of these two conditions, S is a complement of the R, or R is complement of the S. So now if I connect, so if you connect the one inverter in between the S and R, so it will become the D flip flop. If you connect the one inverter in between S and R, because I need only. So if you connect the one NOT gate, you never can see this 0 0 and 1 1 combination. Whatever, suppose if we give input 0 here, 0 will come here and 1 will come here. If you give 1 here, 1 will come here and 0 will come here. So you can never see this 0 0 and 1 1 combinations. Okay, so for that I need the one NOT gate between S and R. Okay, now if suppose if clock is 0, okay, whatever my input, if input don't get anything if I give, it's like a, so suppose if clock is 0 for SR flip flop also, if you give any input for clock 0, there will be the memory effect. Okay, now if you give clock 1, clock is 1, now D is 0. D is 0 means S is 0, R is 1. For this combination, if you try to recall the SR flip flop output, so Q is 0 and Q prime is 1. right? If S is 1, that means that these two are NOT gate is connected, right? S is 1 and R is equal to 0. So for that Q is 1, Q prime is 0. Okay, so this is the about the D flip flop. Okay. Here also because if you give as a 1, S will be 1 and R will be 0 only as the inverted connection is there. Right. So now if you want to write the truth table for D flip flop, how will write? Okay. So D flip flop. Okay. D you are giving Q and Q prime. Okay. Suppose for clock 0, whatever D will give memory effect. Okay. Memory. Okay, so now clock is on. If you give 0, okay, your Q will be 0 and Q prime will be 1. Now clock is 1. If D is 1, if Q will be 1 and Q prime will be 0. Okay, similar output you will get. Okay, whatever D you are giving, similar output you will get in Q. Whatever D you are giving, similar output you will get in Q. If D is 0, Q is 0, Q prime 1, D is 1, Q is 1, D is 0. This is the truth table for D flip flop, right? So now we want to write the characteristics table. So characteristics table means if you try to recall in characteristics table, suppose I am giving clock on this, I am not considering memory effect, I am not considering, I am giving clock as 1. Okay. So in case of the characteristics table, you will have the Q, only Q in the form of the Qn and Qn plus 1. Okay. So Qn is the past state and Qn plus 1 is the present state. Q prime is, there is no concept of the Q prime in case of the characteristics table. Okay, in characteristics table only the Q is there in the form of the past and the present. Okay, so now clock is 1, so if your D is 1, D is 0. So if your Q is 0, past input is 0, but it will not reflect like the present. So whatever D you are giving, you will get same output at the present. Again D is 0, suppose your past output is 1. Okay, again it will not reflect here. So whatever input you are giving, it will reflect here only. Now again, now you are giving logic 1 to the D. Okay, whatever you past value, suppose past value is 0, it will not reflect here. The same output you will get. Okay, as compared as same as input. So here also D is 1, past output is 1, again it will reflect only here. So it will reflect here only. Okay, this will not impact on the past value. Okay, you can see the same D you are getting at the present output. This is about the characteristics table. Now if you want to write the excitation table, so from characteristics table you can create the characteristics equation. Characteristic equation, for characteristics equation you have to use the D and Q. So because this Qn is used as a input for present state. Okay, so you will use the D and Q as inputs and Qn plus 1 as the output. Okay, this is about the truth table. So if you have the truth table, you can get the logical expression, right? So we have the two variables. You need to use the two variable truth KMF. Here is D 0 1. Here is Qn 0 1. Okay. So in which combination I have Qn plus 1, 1 0 and 1 1 combination I have Qn plus 1. So 1 0 I have 1 and 1 1 combination I have 1. Okay. So I am doing this as a pairing. Now what will be your Qn plus 1? Qn plus 1 is, so D. Right. So from truth table also you can see your Qn plus 1 is same as D. From the KMF also you can see that your Qn plus 1 is equal to D. Right. Here you can see. Now your excitation table. In case of the excitation table, Qn, if you try to recall the previous lecture, Qn and Qn plus 1 both will be in the left hand side, both will be acted as the input, and the D will be, in case of the SR will be acted as the output. Here also in D will be acted as a output. Okay. So, so for two inputs means I am writing four combinations. Okay, 0 0 0 1 1 0 1 1. Now I will write this excitation table from the characteristics table. Okay, 0 0. If both are 0 0, D is 0. Qn is 0, Qn plus 1 is 1. Qn is 0, Qn plus 1 is 1. Output is 1. So Qn is 1, Qn plus 1 is 0. Qn is 1, Qn plus 1 is 0. 0. Okay, both are 1 1. Both are 1 1, D is 1. So this is about the acceleration table, right? So this is the truth table, this is the characteristics table, characteristic equation, and the acceleration table of D flip-flop. Now here I told that you can connect the clock of or activating the D flip-flop. If you remove the clock, you can have the memory effect. Okay. So there will be the two kinds of the clock. One is called the positive clock, another is called the negative clock. Okay. So I will I will tell the now what is the difference between positive clock and negative clock. If you apply the positive clock, what will be the output? If you apply the negative clock, how the output will change. Okay, this we will discuss now. Okay, so suppose this is the suppose this is the D flip flop. Okay, so two kinds of the clock you can give here. So you can see I have mentioned on bubble in this clock and here no bubble is there. That means when I am giving only direct clock connection, that means the clock will be active, the D flip flop will be activated when you give the only clock signal as a 1. Okay, in this case bubble means you are connecting clock here, but here only one NOT gate is there. Suppose if you give the clock as a 0, so in after the NOT gate it will be 1. So for this case the D flip flop will be activated. Here if you give the 1 directly it will enter into the D flip flop. So when you give clock as a 1 the D flip flop will be activated. Here if you give the clock as a 0, that time it will become the 1 after the NOT gate and then it will become the activator, just opposite to each other. So this is called the positive clock, this is called the negative clock. Now if you draw the clock signal, repetitive signal, okay, so 1, sometimes it will become 1, sometimes I am giving the clock signal, sometimes I am removing the clock signal, like this. It is a repetitive signal, okay. So positive clock means when it goes from the 0 to 1, okay. When the transition happens from the 0 to 1, this is called the positive clock, okay. Now when there is a transition from 1 to 0, that means it will be 0. When it is 0, that time the clock will be activated. When transition will become the 1 to 0, 1 to 0, then it will become the negative clock. Positive, this is called the H trigger, positive H trigger, and this is the negative H trigger. There is a level trigger that we will discuss later, okay. So positive H trigger and the level negative H trigger. Level means when the clock will be 1 for a certain period of time, that is called the level trigger. H trigger means when there is a transition from 0 to 1, at that moment only the clock will be activated. This is called the H trigger flip flop. And when the clock will be 1 for a certain period of time, how long the clock is 1 for a certain period of time, that period of time the clock will be activated. So normally we used to prefer the H trigger as compared to the level trigger, okay. Now suppose I am drawing a one D input, okay. Okay, this is my D. Okay, now in case of the what will be my Q for positive H trigger? What will be the my Q for positive H trigger? So D is 0, after that it will 1, here it will become 1 like this, it is 0 1 0 1 like this. So in D flip what will happen if what will be the output? The same as the input only, right? So now in case when the D flip Q will be, when you will get Q, okay, when Q will be changed, okay, if there is a transition between 0 to 1 for case of the positive H trigger, right? Now at this moment you can see, at this moment your D is 0, that is your Q is also 0. Now at that moment it is negative H trigger, okay. As my Q is changing, D is changing, but your Q will not change, okay, because at that moment D flip will not be activated, okay. Then memory effect, okay. If you give whatever D input, but it will be have memory effect. Now at that moment you can see my D is 1 and clock is also activated 0 to 1. Then whatever input you are giving, same input will be reflected at the output. Okay. So again it will retain the same value. Again here it will also retain the same value. Suppose it will doing like this way. So again it is 0 here, it will become 0. Okay. Again it will 1 here. Okay. Whenever I have the positive edge trigger, it will reflect the D value. Otherwise it will retain the previous value. Again I am telling here, my D is 0, positive edge trigger, Q is 0. Here, okay, in this case you can see, in this case it will not change. If D is changing but clock is not activated, it will not change. Here clock is also activated, D is 1, so same value will reflect at the output. Okay, here also it will not, nothing will happen. Here again, so D is 0, same value reflect here at positive edge trigger. In this way it is rating. So now if we want to write the output for negative edge trigger, now the clock will be active, D flip will be activated in this, in this, in this, in this. Okay. Now at that moment you can see, at that moment nothing will happen. Okay. At that moment only the D flip flop, D output will reflect here. This one. Okay. Now at that moment also the D is 1, same. Now at that moment also D is 1, same. At that moment also your D is 1, same. Okay. That means when and the negative edge trigger, whatever D values is the same value will be reflected here. Yeah, in positive it will not check the positive value. If positive value is there, the RQ will not change. If negative in negative edge trigger, the Q value will copy from the D flip flop. Okay. So this is about the D flip flop. And positive edge trigger, negative edge trigger. Now come to the next flip flop is the JK flip flop. In case of the JK flip flop, now so what is it in D flip flop? What we have done? We just don't we do not use the 1-1 combination from SR flip flop. We just use the 0-1 combination and 1-0 combination, right? If we give the 0 input, output will be 0. If we give the 1 input, output will be 1. If we want to store 0 and 1, for that we need the D flip flop. If we remove the clock, the same value will be retained inside the D flip flop. Now come to the JK flip flop. In case of the JK flip flop, if we want to use the 1-1 combination, okay, from the SI flip flop, we need the JK flip flop. Okay, so I am writing, doing the JK flip flop. In the case of the JK flip flop, suppose this is SR clock. Okay, so that Q prime will be entered into the here first NAND gate, top NAND gate, and Q will be entered here. Okay, Q prime is connected to the first NAND gate, and the Q is connected to the this NAND gate. Then it will become the J and K. Okay, so if you design the acetylene in such a way, in this way, then you can use the 1-1 combinations. There will be no invalid state for 1-1 combinations. Okay. Now, for other combination, it is same as the SR flip flop output. I will just discuss the 1-1 combination. What will happen in case of the 1-1 combinations? Okay. Now, clock is 1 and you are giving J and K both are 1. Suppose assume Q is 0 and the Q prime is 1. Okay, right? So what will be the output here in this case? Okay, suppose it is S prime, it is R prime, right? Q is 0. So what will be the output of this S prime? S prime I am writing. Okay, so here J is J is 1. So in first NAND gate, J dot this Q prime is coming here and clock is coming here. Okay, what will be the S prime? J is 1 dot Q prime is also 1, clock is also 1. So it will become 0. What is the R prime? R prime is K dot Q dot clock prime. Okay, So K is 1, Q is 0, clock is 1. 0, it is 1. Okay, right? So S is 0, R is 1. In case of the SR, S is 0, R is 1 means SI. This is now lags, right? NAND lags. So what will be the output? Output will be Q is 1 and Q prime is 0. If you try to recall the SR NAND lags, okay? If S is 0, if S is 0, R is 1, Q will be 1 and Q prime is 0. Whatever, suppose I am assuming that my previous value Q is 0 and Q prime is 1. Now Q will be 1 and Q is 0. Just opposite. This is called the toggle condition. So if you give both input 1 in case of the JK flip-flop, so output will be toggle. Okay, if 0 is there, 1. If it is here 1, here it is 0. Now assume that your past value Q is 1 and Q prime is 0. What will be the S prime? Okay, S prime will be your J is 1, Q prime is 0 and clock is 1. What will be the S prime? S prime is 1. What is the R prime? Your K is 1, Q is 1 and clock is 1. R prime is 0. If S prime is 0, R prime is 0. So here Q will be 0 and Q prime is 1. If you remember that, if this is 0 and this is 1 and this is 0, it will be 0 and it will be 1. Okay, so that means this is my past values, these are my past value, it toggle the present value. 1 is changed to 0 and 0 is changed to 1. Okay, so other combination will be, I am not discussing the other combination will be same as the SR flip-flop only. Okay, now for case of the 1-on combination, you can see whatever my past value, it toggle the previous, it complements the past value. So present value will be the complements of the past value. It is called the toggle condition. Okay, now I am writing the truth table for JK flip-flop. J, K, Q and Q prime. I'm considering clock is 1 for all combination. 0, 0 memory. 0, 1, 0, 1. 1, 0, 1, 0. For 1, 1 toggle condition. Whatever your past value, the opposite of past value will reflect in the present. Okay. This is the truth table. Now I am writing the characteristics table. Okay, same way I am writing. Characteristics table. In characteristics table, what will happen? J, K and Q will be written in the form of the Qn and Qn plus 1. Okay, 0, 0. I am giving 0, 0. Q 0, 0 means memory. Okay, the past value is 0, present value will be 0. Past value is 1, present value will be 1. Now 0, 1. In case of the 0, 1, whatever my past value, it will not, so it reflects the J. Okay. It reflects the J value at the present output. Okay, whatever my past values are there. 1, 0, it is 0. It reflects the again J value here. It reflects the J value or whatever my past value. Either it is 0 or it is 1, it reflects the J value. Now I come to the 1-on combination. In 1-on combination, if my past value is 0, it toggle. Okay, past value is 0, then complement of past value in present value. Again, if my past value is 1, complement of past value in the present value. 1, 1 means, so these are the toggle condition, the set, reset, now it is memory. Okay, this is the characteristics table for JK flip-flop. So now if you have the characteristics table, you can write down the characteristics equation. Okay, characteristics equation. So in characteristic J, K, Q, these three are inputs and Qn plus 1, this is the output. Okay. So J, K, Q, here I am writing. Okay, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay. So I will put the Qn plus 1 value in the KMF. So for 0, 0, 1 combination, I have the 1, 0, 0, 1, 1. For 1, 0, 0 combination, I have 1. 1, 0, 0 combination, I have 1. 1, 0, 1. 1, 0, 1, I have 1. 1 1 0 1 1 0, I have 1 and 1 1 1. Okay, so this will one create a quad and this will create a one pair. Okay, so what will be the qn plus 1? Qn plus 1, this is the j. Okay, right? Excellent. I am checking again. Sorry, for 1 1 it is 0, na? It will not come here. Okay, this is now not come here, only this one. Okay, so I am doing this as a pair and these two as a pair. No quad is possible. Okay, so from this pair it will you can write as a j plus qn prime, plus from this pair you can write as a k prime qn. Qn plus 1 is equal to j qn prime plus k prime qn. This is the characteristic equation of the JK flip-flop, right? Now I am writing the last one, acceleration table of the JK flip-flop. Okay. From characteristics table you can write the acceleration table. In acceleration table what I told, qn plus 1 will be in the left hand side and j and k both are in the right hand side. Okay. So I am writing the qn plus 4 combinations I am writing. Okay. So if qn plus both are 0 0, value of jk is 0 0 again here. And if both are 0 0, here it is 0 1. That means j is different, same, but k is different. That means 0 and don't care, because the k at one time k is 0 and other time k is 1 here. Right? Now come to the 0 1. In 0 1, I have only 1 0. No more 0 1 is there. Okay? In 0 1, only 1 0. 0 1, 1 0. In 1 0, you can see in 1 0 only 0 1, 1 0 0 1. Now 1 1. Now you can see two 1 1s are there. Okay, under the qn plus 1. In 1 1 it is 0 0. In this 1 1 it is 1 0. Right? So 1 1 means don't care 0. Okay, so this is about the characteristic acceleration table of the JK flip-flop. 0 0 0 don't care. Okay, for 0 1 you can see. Oh, sorry, 2 0 1s. In 0 1 it is 1 0 and for 0 1 it is 1 1. Okay, so it is means 1 don't care, and 1 0 also 2, you can see 1 0 also it is 0 1. One more 1 0 is there, 1 0 1 1. Okay, 1 0 0 1 1 0 1 1. So it is that means don't care 1. Okay, so this is about the acceleration table of the JK flip-flop. The next class I will discuss the master slip JK flip-flop and the T flip-flop. Thank you, and don't forget to like, share and subscribe my channel.